Thanks for everyone for being here. Welcome to yet another edition of Defender Fridays, this wonderful, wonderful place where we all get together and establish a weekly rendezvous of some of the best people that you'll find in information security, blue teamers, red teamers, seasoned professionals from across the globe, I think, maybe. I'm not sure. Our aim is simple. We want to foster a collaborative space, want everyone to talk, share ideas. Let's have some fun and go over some really cool things. So here we are. Each week, we got a different guest. And this week, I think, Michael Smith, you are our guest, sir, if I'm not mistaken.
I am a guest.
In that case, then I'm just going to hand the microphone over and say, tell us about Mr. Smith.
This is good. I like this. My sales teams do this. So I'm a CTO. My sales team, sometimes they're like, and here is Mike. It is like, throw a mic on stage and then they play the accordion and it's like, dance, monkey, dance.
Yep.
So let's do it. So I'm Michael Smith, hard to find on the internet. I work for a company called Vercara, CTO type, field CTO type, which means I do all the CTO stuff, but I don't have to deal with executive management junk. My background is, I started the world in signal intelligence, was a Russian speaker, Serbian speaker, did that, taught myself Linux, LAMP stack programming right around the last couple of years of the .com era. That bombed out and I said, well, okay, I've got all these skills. And so I moved to DC and I worked on a bunch of different government projects. Worked for a small internet startup called Akamai for 10 years. Taught them what a web application firewall was, how to use it, ended up running their incident response team. A little bit different scope than most incident response teams because we were focused on web protection, infrastructure protection, distributed denial of service, right? Mm-hmm. So really like web DNS infrastructure heavy sort of background. I was a CTO for a company that taught DFIR for a while. Okay. And today what I do is my company is infrastructure and then security, but we operate a large authoritative DNS, so holding zone information, a large recursive DNS. So we're a resolver. We just resolve, we resolve queries, DDoS mitigation, web application firewall, CDN, bot management.
So that's awesome. Dude, I just got to ask, just because I don't talk to a lot of people who do this, what is it like staring down the cannon that is pointed at Akamai?
Yeah, it's interesting. A lot of stuff is really passive detection, right? The vast majority is passive detection. Why? Because CDN, and it's not just Akamai, it's a bunch of other stuff, of other CDNs that are out there. But a lot of their protection is just passive. It's absolutely passive because when you have a lot of bandwidth and your service functions as a web proxy, right? It's a highly distributed caching reverse web proxy. So people send you requests all day, you answer them. And if it's junk traffic that somebody's sending to you, it's not proxy safe, right? You receive it and you go, I don't know. You just drop it on the floor. So there are huge categories of attacks that just don't go, you just drop it, passive.
Yeah.
But then there's maybe 15% of DDoS attacks specifically that are legitimate HTTP with a host header where you need to do rate controls and a bunch of other stuff in order to detect it. One of the things that I did a lot of back in 2012, so it was in September of 2012, the Al-Qassam cyber fighters arrived on the scene, right? And they're like, hey, just out of nowhere, hey, we hate you. We hate, and I quote, the capitalist Zionist banks. And because of that, and because there was a cartoon in some newspaper in, I think it was the Netherlands one, we're going to attack the US banks. which the connection was completely loose. It was totally astroturf. Like, let's pretend that we're hacktivists. But I had my playbook for that entire thing. So there was, okay, so some of their attacks, okay, we passively protect, no problem. Others, you used a combination of WAF rules. So if the HTTP request looks like this, right? It might be user agents. It might be like anytime you make an attack agent, you use some kind of a library. So that library, well, not always, but most of the time. So that library has some kind of signature. So you say, oh yeah, we're looking for that. Or you have some kind of pattern. And so we have rules for the patterns, and then just overall like rate controls. Right. So you count the number of requests, from a source IP address, and when they exceed a threshold, you cut them off. It's like managing the buffet line, right? Like, you've been through this buffet line 10 times. There's no way it's just you that's eating off this plate. Like, come on, man. Right. And so we put them into the penalty box for a period of time. So
interesting.
It's interesting fighting DDoS in a couple different ways. One is that most of the time it's routine, right? And even like today we do network-based DDoS in my company, right? So you use BGP, you route the traffic through our POPs. That runs, we do flow monitoring. When thresholds are exceeded, then we shunt you to the scrubber. We clean up all the traffic and go. But there's so many attacks. Like, the average attack we see is 10 minutes and, maybe less than 5 gigabits per second in attack traffic.
Really?
And it's like, yeah, that's because you get a lot of like, here's a little probe, here's a little probe, here's a little probe. It's kind of like vulnerability scanning, right? You get all of these small, little, discrete, like, okay, an alert fired, we mitigated it, move on. And so most of the time it's relatively boring, steady state, kind of, just chugging along. Like, oh, the stuff worked. It, like, all the kit worked. It did what it was supposed to be. It's kind of boring. And then there's that like 1% of the time where it was like, oh, wait a minute, that's something new. How do we deal with that?
That's awesome. Right? So Jeff asked, Jeff, go ahead.
Hopefully that vacuum in the background isn't too loud. At 5 gigabits per second, is that like barely a blip on the radar just because you can distinguish it? You don't have to care about it mostly?
It is. There's a lot of selection bias. There's a lot of attacker behavior.
Yeah.
Okay. And selection bias in that until a DDoS attack gets to a certain size, we don't even send it to mitigation. We're like, okay, cool. Like, yeah, there's an increased traffic level, right? Is it necessarily dangerous? Probably not, right? But once it gets to a certain size, then we mitigate it. Also, we have a lot of customers that are on demand. So they set up a GRE tunnel to the back of the scrubber. They set up everything so that they can advertise the routes through the front of the scrubber. And then they just sit and monitor. At some point when they say, wow, this is so big, we can't deal with it. Boom. Then they flip it over to us using BGP. Okay. So there's another selection bias there. But the vast majority of attacks are either probes. So it's somebody, they found a target, right? So they say, we hate foo. Let's go attack foo. They rent time on a bot, or they built a bot and they say, okay, let's throw an attack at foo. And then they look at the effectiveness. They're like, is there an impact? No. Let's change. Let's launch another attack. No impact. Let's change. Or they do what we call carpet bombing attacks, where maybe you have a /24. Most big data centers and data center operators will have multiple of those inside of an AS. But what they will do is they will rotate through that AS and say, set 30 minutes of traffic to target 1, 30 seconds, to target 1, to target 2, and they'll roll through all of the IP addresses there Depending on how you count that, that might be 254 attacks, or it might be just one bigger attack campaign. Right. And so you see a lot of those little small ones where, smart attackers know how to do battle damage assessment. They know how to tell if their attack is having an impact.
Out of first comment, your military is showing with battle damage. Just level setting for a moment. We have application layer denial of service and traffic-based denial of service. You're mostly talking about traffic-based here.
And protocol. There's also protocol-based denial of service.
Are we talking about reflection style attacks? Like
it's both of those. It's both of those, right? It's both of those different characteristics, different way to measure them. And then even inside of just, network traffic attack, people call them volumetric, which make me laugh because it all has volume. That's a denial of service. It all has volume. But like your network-based attacks, your application layer attacks, or your protocol attacks sit in this. Okay. They have different characteristics. So your network type attacks, they've got gigabits per second. They have packets per second. And that's how you measure them. Okay. And gigabits per second fills up your circuits. Packets per second crashes your routers because they're trying to keep track of how many sessions or transactions. Okay.
And to level set, if the traffic is going directly to one of your clients through BGP, like they're directly announcing, you talked about switching over BGP earlier.
Yep.
If there is more traffic coming through than you have circuit, more than you have a pipe to the internet, until you swap over, you can either get your ISP to intervene and block traffic upstream, or you can switch over your IP ranges to somebody else, BGP style attack or BGP style swap over that you were talking about before. But to be clear, you're pretty much bones to do anything on your own. If you are receiving more traffic than you have a pipe to the internet. Is that correct? So okay.
So yeah, for a value of you that would not be me. And by that, what I mean, I'm being snarky. Yes, I get it. But we have 15 terabits of network ingest. Okay. And so it's some days I just I think about it and I'm like, wow, okay, cool. But let's see. Yes, for the average operator that's out there, and this is one of the things that vendors and myself included do, is they talk about the big attacks. Okay. Like big attacks, like 1.3 terabits per second of attack traffic. The reason that we do that is because there are only a handful of players in the world who have the capacity to deal with that much volume of DDoS traffic. Right? And we're one of them, right? The other thing for us is we look at what's the size of the largest recorded attack, and can we absorb 3 or 4 of those concurrently, plus all the clean traffic from our customers. And we have a lot of customers that are always on, they're constantly routed through us. And so we have to look at that capacity planning, and you can't just grow capacity of mitigation overnight. So we have to be on kind of this growth curve. So we are a certain amount of headroom, like in canning, you leave the space at the top of the can. But we have a certain amount of extra capacity that we have to reserve just for that kind of a contingency. But the vast majority of DDoS attacks are quick, fast probes that we block. Not a big deal. Most of the time, our mitigation kit does its job, like no human has to get involved. But for the exceptions there, it really comes down to operators who can understand, hey, what's getting through? What are we not blocking that we need to block? And managing targets that aren't behind protection for whatever reason, right? You're kind of it goes back to this security thing, right? Like a security operator mindset, which is all of the technology does its job. The operators manage exceptions, right? you're like, oh, that didn't go the way we thought it would. Like, how do we fix that part? And for a lot of times it's, here's a new target that we didn't think of. Can we onboard it in some way as quickly as possible?
Right. Right. I'm curious, Michael, I read a little bit up before this and stuff, and I noticed that in some cases, DDoS attacks will be reported in requests per second, and in other times they'll be reported in bandwidth.
Yep.
Between the two, is there any clear discerniable difference or any reason to choose
Yes, there
one or
is.
the other? Yeah.
Yeah, there is.
I think
Yeah, there is. And let's a part of it's a vendor thing, right? So we usually measure stuff in gigabits per second or packet per second, because most of our protection is most of the attacks and most of our protections are at the network layer. Okay. When you start using requests per second, that implies HTTP. Right. So if your like target is a website, or you happen to sell a cloud WAF like we do, or you're a content delivery network, it makes sense to use requests per second, because in most cases, the CDN players, they can't really measure the bandwidth.
Right.
Okay, because all they have sensors for or monitors for is number of requests per second.
Gotcha. Okay. Makes sense. That's a good difference, I think, to understand. I was reading, I guess, like August last year, Google Cloud mitigated, I'm reading off of the AI summary here, the largest attack in history, peaking at 398 million requests per second over a 2-minute period. So very short-lived, but very high in volume.
Yep.
I'm guessing there. Interesting.
Yeah, and that happens quite a bit, right?
Yeah.
It's really kind of weird. Some days it's like the aliens. They just show up, they send attack traffic your way, and then they disappear.
It sounds more like a botnet operator flexing for a couple minutes and then going back to their daily life.
Sometimes, yeah. So we did a lot of just OSINT stuff around Killnet, Russian DDoSers. There's a whole like ecosystem, and it's worse than open source projects, right? It's like, hey, let's build a new one, and everybody gets involved, and then they're like, oh, I hate these guys, and so they fragment, and then there's another group, and then another. Like, it's kind of this weird Wild West ecosystem. But we started looking at what they do, and it was interesting. I started to become interested in them back in October of 2022, where out of the blue, they show up and they're like, hey, we just caused an outage for 20 US state websites, right? And you're like, okay, like, all right. And it's like Idaho, right? So like, I grew up in Idaho. Nobody, Idaho's website, like, I'm sure, I'm sure the Idaho state government cares, right? But
unless it's April 14th, dude, then everyone cares.
Then everybody cares.
Yeah.
I get that. Or it's Idaho. You have to go buy, it's January 1st and you have to go buy a new hunting and fishing license. Yes. Right. But otherwise it's kind of like, meh. And so one of the tactics that Killnet and all of their types do is they will actually go out and probe and find targets that aren't defended and then cause an outage, and then you could actually see them, like they go into their staff meeting. They don't have staff meetings. They go into their staff meeting and they're like, hey guys, how do we justify this? Like, what's our story? They just find easy targets. And then they try to rationalize it later, because it's not really about the attack. It's about publicity, and it's about intimidation. And that's what they're trying to accomplish.
Interesting. I like that. I like that. I like it in that I like that it's happening. I like sometimes it is they have their own way. Threat actors have their own way of like proving their worth or proving their skills and capabilities and things like that. And I think there's got to be a little bit of distrust when you're advertising, hey, I can launch this type of attack, and someone's like, well, I want to pay for that, but prove it, right? Show that it's out there. I think it's a really wild thing to think about.
And I'm going to tell you the shocker.
Yeah.
The horrible shocker in this world. It'll completely mess up your sense of reality. Criminals lie.
No, nah, get out of
I
here.
know, I know,
Come
I
on.
know.
I heard they were all honest thieves.
All honest thieves.
They're not honest thieves. But yeah, they do some demonstration attack. But in this case, what they want is they want to basically say, hey, wherever you're at, we can touch you.
Mm.
And they have, moderate success. They're really careful about what targets they have. So like I always say, it's like the Soviet space program, right? They'll launch 10 rockets into space. 9 of them will burn up on the launch pad. They don't talk about those.
Yeah.
But the one that actually goes into space, they're like, oh, look at us, break our arms trying to pat our back. Like, yeah, right.
Interesting. Mike, I got another question for you. Came in. Someone asked a little bit earlier. I apologize, John, for not getting this question earlier. Has the growth of attacks trended over time, and then subsequently, has it scaled with IoT devices or any other reasons?
So attacks over time, yes.
Mm-hmm.
It has drastically increased. My marketing people will be sure to tell you. I love my marketing people, but they're always like ever increasing attacks. Yes, then the quantity and the size and the magnitude of attacks is going up over time. Mm-hmm. The reason that it doesn't make the news is because of folks like us. We block so much stuff that market-wise it becomes a problem for us. All right. So we're like, hey, really, this stuff happens. And everybody's like, okay, prove it. So one of my remits, my existence or my reasons for existence right now is collecting traffic statistics and talking about those just so that as a company, people know that we're doing things and we can help them. Right. This does lead to this weird cycle of DDoSes and it's a cyclical thing. 2 years, you don't hear about anybody getting attacked.
Yeah.
And for 2 years after that, everybody's getting attacked and you hear about it all the time. And what happens is during during the DDoS winter, right? The time where it's quiet.
The development phase.
Yeah. Yeah. Well, the attackers are focused on other stuff, right?
Right.
And so during that time, people are like, well, I don't need protection from this. I don't need to renew my mitigation vendor contract. You don't do testing. You don't do on-ramping to test, does your stuff really work? Can you still flip to mitigation? You don't train your staff. And, over the course of 3 years, they leave and go work for somebody else. And every time when the cycle starts again and you start getting attacks, everybody has to relearn the stuff that they knew 4 years ago.
Mm-hmm.
So we're constantly forgetting and rebuilding. It's kind of like the U.S. military going to war, right? Other than that, like this millennium. But before that, it was, hey, we fought the Revolutionary War. We want to never do that again. And like, let's get, retire all the soldiers. And then, War of 1812 happens. Whoops. We need to figure out how to build a military again. And they've done that every single conflict. They're like, okay, we don't need this anymore. Let's tear it all down. Everybody forgets how to fight it. And then, we have to go relearn how to do it.
Start over again. Yeah. Oh, wait, hold on. We had these skills. What happened to them? Where'd everybody go?
Yep. Where did everybody go?
John Woodling wins something, I don't know what, for the best comment ever. If you're a Always Sunny fan, that was fantastic, John. We haven't used this in a while. Why do we keep it? Terminate the contract. The gang gets DDoSed. I love that. That's well played. Very nice. Michael, I got to say, I kind of wanted to equate you to like Batman for a minute there because Batman keeps crime out of Gotham. So when people are like, there's no crime in Gotham, it's like, no, because there's someone keeping it away and stuff like that.
I use the Batman analogy a lot, but from the other hand, which is you get the hero you deserve, not the hero that you want.
Okay.
Right. And as somebody who self-identifies as chaotic neutral, sometimes, you get the evil Mike and sometimes you get the happy, good, maybe not lawful, but, good intent Mike. So
there we go.
It just all works.
Yeah. It's a combination of hats that you've gained over your career. Yeah. If you will. Yeah. There we go. That's awesome. I like that. Curious, every time I think John was close to asking this earlier. Every single time there's some sort of big attack these days, there's always some attribution to like, oh, now we have all these IoT devices. And I just wanted to pick
Oh
on that
yeah.
trend. Is that true? Like, is my refrigerator DDoSing Google?
It's not always.
Yeah.
It's not always. It's not always. In fact, most of the stuff is like all the cool kids now are going to cloud providers. They're going to, virtual private server hosts.
Yeah.
And there's a project called Build Your Own Botnet. And you like literally you just go get a virtual private server or a cloud server. You install the software there, you point it at your command and control, and then you run the management interface someplace else. It's similar to back old school. You're dealing with booters. So booters were the first ones, and it's a web application. So you go compromise a web server, you stick your software there, it gives you a web interface. Sometimes you can federate these together, and then you can say, oh yeah, here's the target. And they were actually built by people they're called booters because you could play Counter-Strike, find somebody's IP address and kick them off the game server by DDoSing their own home network connection. So
Nice.
it would boot them.
Yeah.
But it's extension of that same concept. But that's what a lot of the cool kids are doing, and that's what a lot of the Russians and Killnet and those guys are doing, is the build your own botnet route.
Okay.
But
what kind of bandwidth do you get out of that?
It depends. I'm a security guy. You get the security guy answer. It depends.
Good answer.
It depends on how many nodes. Like, it's simple math. How many nodes do you have your bot deployed on?
Okay.
And what's the average bandwidth to each node?
Gotcha. Makes sense.
Go
ahead.
And you have like different, different attacks have more volume. Some are more leverage. Like if you do amplification, you get more leverage out of it. If you know how to target, so you go in and you do reconnaissance and you do some vulnerability scanning and you understand the application stack, the more you understand the target, the more utility you actually get out of your DDoS attack.
Okay.
And so, yeah, right. Now, IoT, because I haven't actually answered the question.
Yeah.
It was like, I told everybody how to build a watch, not what time it was. But IoT devices, yes.
Mm-hmm.
And if you go back to October of 2016, which was when all the Mirai attacks happened.
Yep.
Right. And it was Brian Krebs and Dine, and basically a third of the internet died. Okay. Variations to Mirai, or Mirai workalikes or sub variations of Mirai still exist. They're out there and they are being used to attack things.
Mm-hmm.
But Mirai was a combination of problems, right? So you had controller chips for cameras, for internet connected cameras, that all used the same firmware. That firmware had the same operating system password. That firmware had SSH and Telnet enabled by default. That firmware used SSDP, so Simple Service Discovery Protocol, to open up incoming firewall ports to the device, including the remote management, services, right? So Telnet, SSH, or login, stuff like that.
Gotcha.
And a lot of home routers had SSDP enabled by default. So all of these vulnerabilities chained together is how you go out and you scan and you find these cameras, you compromise them, you upload your own firmware, and then you send them to the same command and control.
Are they actually reflashing the firmware, or essentially adding one new binary of BusyBox or whatever, or their C2 software?
Yeah, it depends on the device. It depends
It's
on
like
the device.
it's finicky to
But, yeah.
reflash firmware. Generally speaking, it's per device.
It is in fact per device, but they're all the same chip and all the same firmware. So, right.
Yeah.
So which comes in handy. But so we run a web application firewall, and one of the things that I do with it is I set up a bunch of honeypot sites. So I've got a bunch of websites, and I go and I record, like I go to the, the vanity domain providers, and I register like VPN dot and www dot and SMTP dot. And so I collect all of the filth of the internet. It's awesome. But
Gotcha.
I see a lot of attempts that are specific to Mirai or functional equivalents of Mirai, just where people are out scanning, looking for devices like that they can compromise. So yeah, they're there. It happens a lot. I think the third thing, so there's build your
Hey,
own
Michael, I
botnet,
hate to say this.
right?
We're
going to run out of time.
We're actually at the top. We've run out of time, believe it or not.
Outstanding.
Folks, we have not yet extended the extent. We have not yet discovered the extent of how much Mike knows about this. But Michael, thank you so much for being here. I know we have a few folks who are looking to head to their next meeting and stuff like that. And we try to keep it, we try to keep it to 30 as much as we can. Can we have you back on at some point in the future?
Yeah, no problem. Ostensibly, we were going to talk domain generation algorithms, but
I know
we never made it there.
All right, next time. Next time, man.
Can do.
Awesome. Michael, thank you so much for being here.
All
Folks, thanks for hanging on for a couple more minutes. I was just so entranced by this discussion, only because it's not something that I feel we get to talk about a lot. But
yeah,
Michael, we'll get you back again very soon.
All right.
We've already got folks like, please come back. So thanks for being here, everyone. This is Defender Friday.
Cool.
I'll see y'all next week.
Cheers, guys.
Same place, same time. I like it. Thanks. This has been Defender Fridays. Thanks, everyone. Have a good day.